Hi everyone, my name is Michael Eilbrock from MJE Diagnostics, and today we are going to go over a case study of a bus that I worked on a while back. The bus number is 328. It's a 40-foot New Flyer transit bus with a Cummins ISC engine and a CAPS fuel system. Yay, yeah, I know, CAPS, that's pretty old, right? Well, it's actually a pretty cool system, and I've got some interesting information here to share with you. So the problem with this bus is it keeps setting a 121 code, which stands for the engine position sensor circuit. We've had a wiring harness put in this thing, and both speed sensors have been replaced on the back of the timing cover. All right, and the speed sensors are located on the back of the camshaft looking at a tone ring that has 72 teeth on it. Okay, service information states that when you have this code, you get no engine speed and position backup for the main speed position sensor. And of course, it tells you to go through a troubleshooting tree that's like 2 miles long, and it's extremely time consuming. So what I'm going to show everyone here is a better way to diagnose this code. Okay, so we've done history, obviously, and it's had the harness, sensors, and all that. So what else could it be? Well, there's something else that needs to be addressed as well with this. Anytime you get a engine position sensor code, or even one for the engine speed sensor on this type of engine. Okay, so what we're going to do is we're going to set up a scope, my pico scope, and we are going to hook into the engine position sensor, the engine speed sensor. We're going to take a current clamp and put it around the ICV wire, the injection control valve. And then we're going to take another current clamp and put it around the battery cable. And we're going to start and crank the engine and get an overall idea of the timing of the engine while it's cranking. And I bet everyone also has another question for me, as in, well, Mike, how do you crank the engine over without it starting? Well, on this type of design, on a CAPS pump, you have the pumping control valves. Those control valves build pressure in the accumulator head to put the fuel through the rate shape tube and into the injection control valve. If those solenoids are unplugged, you can't pump fuel through the accumulator head to get the fuel into the rate shape tube. So I just disconnected both pumping plunger solenoids and cranked the engine over and did my test. So let me show you the capture that I have. As you can see here on the blue channel here, channel A, I have my engine speed sensor. Channel B, the red trace, is my engine position sensor. And then I have channel C is my ICV current with a current clamp. Channel D is the starter current, or in this case I've labeled it relative compression, because I want to see relatively what the contribution is of the engine from cylinder to cylinder. And with the injection control valve current, I can also get an idea of where it's firing in relationship to top dead center. Now, top dead center, looking at starter current, it's not truly top dead center. I like to call it a accurate or reasonable accurate amount of top dead center, because when you go top dead center compression with a piston, there's going to be a little bit of piston float. It's going to stay up there for just a little bit. So, but we can still use this as a valuable diagnostic tool to help us. All right, so let me just walk you through what I did first. So I did my capture. I made sure I had a good sample interval on my scope of 1 microsecond, so I knew that the dots were connecting fast enough from left to right. And after that, I measured my voltages on both my speed sensors, so we can also zoom in here just to get a better accurate measurement of what we have. And at the top here, for the engine speed sensor, I have 4.9 volts, so that's good there. And then I'm going to check where it's going to ground. And I'm at about 116 millivolts. That's pretty good. I'm not too worried about that. And then I'm going to check the other one as well. And I've got 4.9 is there as well. And then I'm checking the zero line on this one too, and I've got about the same, 162 millivolts. So I know my sensors voltages and my ground levels look good, and I don't see really any rising of the signal or lowering of the signal as I'm cranking. So I'm not suspecting that anything that is wrong with the camshaft gear that's on the cam. Okay, so I'm ruling out mechanical with the cam right now. However, if you zoom in here to one rotation of the engine, you can see that my starter current is kind of wavy. It's higher and then low, high, then low. And to prove that a little bit more, what we can do is we can vertically enhance the starter current. And as you can see here, you can see it a lot more defined. So after I saw that, I got some vertical rulers here to measure. So I'm going to go here to this cylinder here. And the reason why I know that this is cylinder 1, by the way, is because I've done tons of known goods. And I've cut it out each cylinder with Insight to prove that this cylinder is cylinder number 1. So the first cylinder that fires before these two notches here, that is cylinder 1. So I'm going to go to the next one, and we'll have to count here just to make sure we're correct. So here's cylinder 1, 5, 3, 6, 2, 4. And then we go back again to 1, and then that gives us one full rotation of the engine of 720 degrees. So I've got them lined up, and now I'm going to do some measurements here of when the ICV valve is firing. So let's zoom in here and get it just right. Go back out, and as you can see here in the box here, the ICV, the injection control valve, is firing at minus 17.14 degrees before top dead center. On a direct injected engine like this, that is way too much. So we have a timing issue here that needs addressed. Okay, so what I have done here with the scope and proved with very good accuracy is I've proved that timing is off. You don't have to pull the cover on the engine. You don't have to do any more work. You know that you have a timing issue, mechanical problem that is going on with this engine. So the next step that I did was I took off the valve cover and I inspected the lash on the rockers, and all of the valves were at their max lash limit. So after doing that, I readjusted everything and I did another capture. Okay, but before we go to the next capture, I want to explain something here. So before, when I've explained this to other students about the timing, and I talk about, base timing, well, if you look at the sensor circuit signals on here, these two are just on the back of the cam. So it's kind of hard to actually state that you're verifying base timing, but my opinion is, though, if you're looking at the ICV, your injection control valve, when it's firing, that is basically showing you where it thinks base timing is at, because the computer is going off of these two sensors on the back of the cam, making a calculation, and then it's firing off of that. So it thinks that base timing while cranking to get it going is, right here where I've measured it out. So that's how it thinks. That's the logic of the computer. But with the relative current here, it's showing it's being off. Okay, so you could have timing mechanical lined up fine on the crank and cam with no issues, but if you have valve train that is out of adjustment, that's going to show up on your starter current because of the looseness in your valves. Okay, so that's the one thing you have to keep in mind when you're looking at an engine mechanical fault. All right, so anyway, let's get over to the next capture, and then we will go from there. Okay, we're back. So I've got the other capture here, and this is after I did the valve adjustment. So let's zoom in on this one and see where timing is at now. So let's get our cursors here. And let's put some filter in on the starter current. There we go. Okay, and we have 1, 5, 3, 6, 2, 4, and then back to 1 again. And let's do our rulers. And let's do the measurement. I'll have to zoom in here a little bit. Okay, so let's line that up right there. And there we go. So it's improved dramatically, the timing. So now it's firing at 2.841 degrees before top dead center. And as you can see here, all the other degree rulers, they line up very close to top dead center starter current on this capture. Okay, so that was the fix. It was just that the overhead adjustment was loose, and when you would go down the road and going under different loads and speeds, the valve lash would fight, with the opening and closing of the valves. If you have opening and closing of valves that are happening too late, then it's going to affect your compression pressures inside the cylinder, and therefore it's going to react with the crankshaft and the camshaft, and then also with the timing on the ring on the speed sensor on the back of the camshaft. And that's what was logging this intermittent code. Okay, and after doing this capture and looking at the timing and everything, I've pretty much come to the conclusion that if you don't have a scope to find these types of problems, you're not going to know. You're not going to know which way to go. And also, if you look in the troubleshooting manual for Cummins for this code, for the 121 code, it has you go through tons of different steps looking at trying to find a short in the wiring and open in the wiring. It even has you wanting them for you to take out the engine speed sensors and look for damage. And, that's not bad. That's actually a pretty good step. But my point is this: I was able to hook up the scope with a few connections, look at my voltages, look how the speed sensors are reacting with the starter current and the ICV valve current, and I was able to very quickly ascertain what was going on with the circuits and the engine and everything without having to tear apart the timing cover, the valve cover. Well, I took off the valve cover, forgive me there, but the timing cover, and go through a lot of steps that I don't need to take because I have a scope. Okay, so good story here. This happened, I would say about 10, 15 years ago when we first had these engines. We had a similar situation on another bus where it logged the same code, and other technicians had tried putting speed sensors in, tried a wiring harness, still didn't work. Then we had Cummins come in, and then they're taking off the speed sensors and trying to look at the camshaft gear, and then to verify that they have to go that way, they're taking off the entire timing cover. Okay, so here's the deal: what if they did all that work and then found out that it wasn't that? All right, with the scope, you can be accurate, you can prove what you need to see, you save time and money too, so but anyway, that's pretty much it. I hope everyone enjoys it. If anyone has any questions about the case study, please let me know. I'd be more than happy to answer all questions, and I hope everyone has a good day. So, thank you.